So now that we have seen that rational exponents really are just roots, and we saw in the last video that x to the 1/2 is the square root of x, now we can generalize that to say that anything raised to the 1 over n power is really the nth root of that thing. Okay, so the denominator of our fraction becomes the power. Becomes the root. Another example would be something like 64 to the 1/3 power. Well, that equals the third root of 64. Hopefully you guys know that to be 4, because 4 times 4 times 4 is 64. Another example, and this gets a little bit more tricky, is when the numerator is not 1. So something like 16 raised to the 3/2 power. The half we already know to be a root. But what I want to do to figure out what happens with the 3 is I'm going to split this up. I'm going to think of it as 16 to the 1/2 times 3. Okay, so 3/2 is the same as 1/2 times 3. And then by our one of our exponent rules, we know that a product is the same thing, product in the power is the same thing as a power raised to another power. So 16 to the 1/2 raised to the 3rd. And so of course 16 to the 1/2 is the square root of 16, and if I take the square root of 16 I get a 4. I raise that to the 3rd and we get 64 again. So another way to represent 64. Now what's interesting is that these two numbers are interchangeable. The 1/2 and the 3 can be switched. And so can then the root and the power here. And so what we'll find out is that if you take the root, raise it to the power, it's the same as taking the power and raising it, or taking the root of it. Okay? So those two things are the same. And so now we have a place for the numerator in this fraction, right? The numerator becomes the power, the denominator becomes the root. And now we can generalize this further to say that anything to the m over n, I'll use m and n for this, is equal to the nth root of a to the m, right? Or it's also equal to the nth root of a all raised to the mth power. So you can do the m on the outside or on the inside. Again, they're interchangeable. And again, we are assuming that the base, the variables are always positive here. Okay? If we don't assume that, if we allow for negatives, then some of these equalities don't hold perfectly. So we're going to assume everything is positive. Okay, so now we can do a couple examples where we just convert these things. So if I did the 3rd root of x to the 8th power, well, I can convert that to a rational exponent and call it x to the 8/3 power. Okay, the power of 8 becomes the numerator, the root of 3 becomes the denominator. Okay, if I did 5 raised to the 7/4 power, then of course we're looking at the 4th root of 5 to the 7th. And so that would be changing from a rational expression, a rational exponent, into a radical. Okay, so you can go back and forth between these two ideas. And of course simplifying when possible. Okay. All right.